video we will explain the movement of robotic arm through leap motion. It is a IoT based project in which we use the hand gestures to move the robotic arm, which is basically a 6 degree of freedom robotic arm. So the first 4 motors basically control the movement of the arm, while this motor number 5 basically control the movement of wrist, and this motor basically control the grabbing hand. Alright. Here we have a buck converter, which basically loading down the 12 volt DC voltage to the 5 volt for this module. This is PCA9685, which is basically servo motor driver. As you can see, there are basically 6 motors are connected with this driver, and we have a Raspberry Pi4 which is basically communicating with this remote through the I2C protocol. Now let's come towards the hand parts. So for the hand parts, we basically use the leap motion device. In this device, you can basically get the movement of the hands. It is widely used in the virtual reality applications as well. If you see here, if I put my hands here, it basically draw all the points on it on the 60 FPS. It's pretty much good. Part is that how we processed our hand gestures to move the robotic arm. For this, we will look on the anatomy of the hand skeleton. There are basically 4 bones here. If you see here, there is a metacarpal bone, proximal bones, middle bones, and distal bones. So we are basically using the bending of the fingers to interpret the gestures for the robotic arm. So to make the things very simple, we basically use the points of the proximal bones and the starting and end points of the middle bones. Then we get the vectors of these 2 bones, and after getting the vector, we take the cross product of two vectors in the 3-dimensional space. So obviously, like if you do your finger like this, the proximal and the middle bone will be in the parallel. So when 2 vectors are in the parallel, the cross product will be 0. That if the angle is like minimum, like 0 degree, 10 degree, 20 degree, it's mean that it is in the 2 vectors are nearly parallel. If I bend like this, now if you see that the proximal bone and the middle bone is not longer parallel to each other. So this is basically the actual and basic fundamental of the processing of the hand gestures to move the robotic arm. Now we will move towards the setting up of the server, and also we will move the robotic arm with it. Here I'm setting the server. When we set the server, it basically go back to its initial position. Alright, so we can also move the motors from here, as you can see. In this part of video, I will explain that how we are processing the gestures from leap motion device to move the robot. So we are using our left hand to select the motor, and the right hand to select the angle. So for example, if I do like this, it means that I'm selecting motor number 0. This is motor number 1, this is motor number 2, and this is 3, 4, and this is 5. So starting from 0, total there are basically 6, from 0 to 5, including the 0. Now from the right hand, there are basically 3 settings. The one is a small data set of angles, in which the angles are like 0, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, and 180 degrees. 7 angles here. This is a small data set. In the medium data set, we have introduced 13 gestures, which are basically just a binary representation of the hand. Like if I bend my hand like this, it means that the value is 0, 1, 1, 1, 1. So you can say that this is 30. And if I do like this, it means the binary representation is 6, because all are the zeros. So we have processed the gestures in the binary representation for the medium gestures dataset and the large dataset. While in the large dataset, they give you the angle difference of the 9 degrees with each gestures. If you do, there are 21 gestures involved in the large dataset. In this part of video, I will show you the live demonstration of the robotic arm. We will move this robotic arm through the leap motion device via hand gestures. Alright, so let's move first this part. Okay, it's already in the 0 degrees. Let's go to the 180 degrees. Okay, good. Now let's move this part. This is motor number 4. Now let's move to the 0 degrees. Okay, so now 90 degrees. Okay, let's move the 90 degrees. Now let's move the base motor here. Alright, so moving the base motor. Okay, we have moved the base motor to the 90 degrees. Let's move to the 180 degrees as well. And let's go back to the 0 degrees. Okay, now let's move the motor number 3 with the angle 90 degrees. Okay, go back to the 0.